Hello everyone, my name is Rojafari and I would like to welcome you to another video of data mining series. This video is going to focus on classification, yet another important and very popular data mining task. Okay, let's look at the slides. Okay, in this video, we are going to go through this outline. We're going to talk about what is classification, and then we see how we would design a classification, which is for the most part very similar to the design of a prediction task. And then we'll see an example, and then we will solve, we show you how we would solve this example using two popular algorithms, KNearest Neighbors or KNN and Decision Trees. Okay, so let's start with a recap. Do you remember what was a prediction task? A prediction task was when we had independent attributes and we were to find the connections between the independent attribute and the dependent attribute in such a way that we would be able to see the patterns and use those patterns to help us to predict the future cases for the dependent attribute. We saw that when we have a classification, we have a prediction task, we use an algorithm to connect these predictors to the target. The only difference that we have, so this was prediction, right? So this was the case of a prediction. The only difference that there is between classification and prediction is that, pay attention here, pay attention what changes here. Is that, before paying attention here, what we would do in the case of prediction, we would, go about finding those patterns that connect the independent attributes to the dependent attribute, and then we would use those pattern that we find for a new object to come to a prediction for the new object. So that was prediction. Again, pay attention here what changes. What classification does is the same as prediction. We are trying to find a relationship between independent attributes and dependent attributes, but for classification, the dependent attribute is a categorical attribute. For prediction, that is a numerical attribute. So this is a classification. Why is a classification? It's because our dependent attribute is a categorical one or a label, right? So exactly like prediction, what we do here, we want to find the patterns that connect the independent attributes to the dependent attributes, so we can use those patterns or those connections for us to be able to come here and use those patterns to come to a class prediction for the new object, class 1 or 2, based on those patterns. So that's classification. That's the difference. So you want to take this home with you. What's the difference between classification and prediction? They are almost the same because they are, trying to find the patterns between and among the independent attributes to a dependent attribute. So this is the same thing for them, but for prediction, that dependent attribute is a numerical value. But for classification, that's a categorical value. So that's all there is to it. So for example, here we have a case study that we want to be able to predict, pay attention, predict whether a customer would default on their loan or not based on their credit score and their income, right? We are predicting an event. We are not predicting a number. That's why our dependent attribute is categorical. Therefore, the way we would design this model, we would design it as a classification model. So you can see how similar this is to the prediction, because we are basically connecting two independent attributes to a dependent attributes. Let me stop right here and talk with you about the importance of these models and how we would go about designing them. Prediction and classification alike, it is very important for us to be able to come up with good and legitimate independent attributes that can help in the prediction of the dependent attribute, right? I mean, for now, for here, we just have this data set, and it's so easy to actually do this stuff, do the algorithm part and the code part. What's really contributory and what really adds value is thinking or imagining what could be these attributes, and then trying to find the ways to find and calculate or measure those values and bring them into one data set that has the potential for the prediction. So that's really that design. I mean, recognizing these independent attributes that can benefit the prediction model, they can help you predict the dependent attribute. I mean, of course, we do know for a loaner, for a credit company, knowing a customer is going to default on their loan or not is significant. So that event, that dependent attribute is significant for them. So how we would design a classification model or classification task, is really more important on what are the attributes that we can imagine of that would be helpful in this prediction. So here, two attributes that of course are important and they are easily available for the creditors is income and credit score. So we have this, and the way we would go about designing this classification is simple. Like, we have two independent attributes and we have one dependent attribute which is a categorical one. So now whatever algorithm we put here, we can find the patterns that exist between these columns, and then once we have a new data object, we use those patterns that the algorithms find to come up to a yes or no for this new data object. So that's all there is to it. So it all comes down to this algorithm now, right? We have done our due diligence and we have meaningful independent attributes and a dependent attribute. So now we want to find an algorithm that actually can find those patterns in a good way. So for example, let's talk about the first algorithm, KNearest Neighbors. Everything you need to know about this algorithm is summarized in its name, KNearest Neighbors. What that means? That means when you have a new object you want to classify, the KNearest Neighbors will have all the say in what is going to be the class of this new object. So let's look at what that means in this example. So in this example, we have these two independent attributes, and we have 21 data objects, right? So we go ahead and draw these on this 2 by 2 on this scatter plot, right? And what we see here is a three-dimensional visualization. We have income and a score, income as the x-axis, a score as y-axis, and the color or the shape of these points as the default attribute, right? So we have been able to draw this, and pay attention here. I mean, this is drawable or like visualizable because we only have 3 dimensions. If we had more, we wouldn't be able to do this visually. We would have to do it using the algorithm. But now we are using the visualization to learn about the algorithm. So what KNN says is find the k-nearest neighbors to the new data objects you are interested in its label, right? So the new data object is here. So this is the new data object with the star, right? So you can see here as well. The new data object is here. So we find the k-nearest neighbors. K is given to us 3. So we find the k-nearest neighbors. These 3 are the k-nearest neighbors. And therefore, because 2 of the neighbors over against 1 neighbor is default no, we would predict no. As simple as that. K-nearest neighbors is that simple. Of course, when you actually get to coding it in an algorithmic way and there is more than 2 dimensions, there's going to be many different issues as far as the coding, computational cost. But the good news for us is we're going to learn actually how to do this using different modules that we'll see in the future videos. But before moving on from KNN, let's also do a KNN when k is 5. So when k is 5, you have to find 5 data objects that are closest to the new data objects. So these 5s are the closest ones. Again, we have 3 no and 2 yes. So in this case, again, we would predict no. Alright, so let's move on to the last part of this video, decision trees. Decision trees are also another algorithm that can handle classification. Decision trees actually can also handle prediction. But here we're going to learn about how it could help us with classification. And then in the future videos, you are going to see decision trees can also be used as a prediction model, as a prediction algorithm. So what decision tree does basically uses the independent attributes to divide the data until you get to a small subset of the data that is definitive, or there is only one type of class in those parts. So the way it goes about that, how it chooses how to divide them, what attribute to use, these are all the material that we are going to cover when we get to decision tree. As that decision tree, we're going to learn decision tree. Here, we're just getting introduced to it, right? So here, we say if the score is smaller than 789, if the score is smaller than 789, then we say no, because most of the people whose score is smaller than 789, they were not loan worthy. But if the score is not smaller than that number, is larger than number, and the income is smaller than this value, which is 110,000, then we also say no. But if these two are met, the score is above some number and the income is also above some number, which we have 10 cases of those, then it's a yes. So that's how decision tree works. But what I want you to take from this lecture is the fact that prediction and classification are very similar, right? You saw that the difference between prediction and classification is that in classification we have a categorical attribute, but in prediction we had a numerical attribute. So what is important here is prediction and classification both goes into the independent attributes and the dependent attributes and find those patterns, package those patterns, give it to us for future predictions. Until the next video.